Hey guys, figured we might as well make this like the classroom, and let's start with a bell work. Today, in general, we are learning power rule, product rule, and quotient rule. Three very important topics, something you're going to do every day from here until the end of calculus. So as long as you're in calculus, you're going to do one of these every single day. So obviously a really important topic, and make sure you're good at it. To start off here in bell work, we are talking about differentiability. This is what we learned on Thursday. Just a quick review of what's going on here. Differentiability means where can you take a derivative? You can take derivatives everywhere, except for when a function is discontinuous, a corner or a cusp, because if it's a sharp corner, it is not a gradual change of slope. It's going to be undefined. And then the fourth place is a vertical tangent line. So those are the 4 places we're looking for. Let's look at this graph. You don't need to see my face this whole time, so I'm going to change it to this little icon right here. That way it doesn't record my face because that's weird. All right, at what values is the graph not differentiable? So as we're looking at this thing, trying to move my computer screen around, sorry. All right, when am I not differentiable? You are not differentiable anywhere that you have a hole or corner or a hole or a jump. That's a vertical asymptote on that first one. But so when am I not differentiable? X is equal to -1, 1, 2, and 4. That's where you're not differentiable. Where you're not continuous, you know what continuity means. Continuity is where you don't pick up your pencil. So boom right there at -1, and boom right there at 2. Oh yeah, and this guy right here at 4. So -1, 2, and 4. Why? Because you have to pick up your pencil. -1, 2, and 4. Notice that if it's in the not continuous list, it is also in the not differentiable list. Where is it continuous but not differentiable? Well, that would be at x is equal to 1, because right there you've got a sharp corner, and if you have a sharp corner like that, you are not going to be differentiable, even though you are continuous. And where are you differentiable but not continuous? Remember, that place does not exist. If you are not continuous, you cannot be differentiable. Not going to happen. So don't get caught in that one. That one's a D&E. Doesn't exist. All right, so let's go to these notes. I posted a blank copy online, but you can print them off, or you can just follow along, pull out a scrap sheet of paper, or not a scrap sheet of paper, but a paper that you can take some notes on, because again, really important topic. We're understanding what's going on. Okay, so we're doing power rule. In theory, this is really, really easy. This is not a complicated lesson, at least to start here, but we're going to make sure we're good at it and understanding how to do it. And so the front page of these notes are a whole lot of examples. I wouldn't have done a whole lot of talking throughout the day. It really would have been more you practicing them and then checking in on you. So that's going to be kind of the game plan, at least me working through it. Sorry, my desk is a mess right now. All right, so derivatives of a constant. If we take the derivative of a constant, y equals -17. That is a line, a horizontal line right here at -1, 2, 3, 4, 5, 6, 7, 8, -17. Well, what is the slope of that line going to be anywhere on that line? The slope is going to be 0. It's a flat line. And so if you have a constant, if you were taking the derivative of any number, just a number without any x, the slope is going to be 0, so the derivative is 0. That's a rule. Okay, if your y value is just equal to a constant, then when you take the derivative of it, it's 0. So what's the derivative of 104? It's 0. We move on to the next question. Constants become 0. Power rule. So here's the power rule. And let me just kind of explain it. If you had something x to a power, you are going to multiply by that power. Take that power, put it down in front, and then subtract 1 from my exponent. So for example, x to the third. We did problems like this. Like we did the limit definition problem. The limit as h approaches 0, f of x plus h. Ooh. We did those. Okay, I could pull up my notes right here and think about what we did here. What day would have that been? Desmos, that one right there. Bellwork. Yeah, that guy right there. Remember that guy? It was fun. That's how we took a derivative. We are now going to do it way, 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 way faster. And so here's what power rule says. X to the third, the derivative of that, we're going to multiply by 3. And and then subtract 1 from my exponent. So it'd be 3x squared. Done. Multiply by my exponent, subtract 1 from my exponent. Multiply by my exponent, subtract 1 from my exponent. Multiply by my exponent, subtract 1 from my exponent. What about x? Well, it's x to the first. So we're going to multiply by my exponent and then subtract 1 from my exponent. Well, that would get me 1 times x to the 0. And we all know what x to the 0 is. X to the 0 is just 1, because anything to the 0 power is 1. So the derivative of x is just 1. Important concept. Make sure we got that. Then we get into fractions. This is when students start to make this a little bit harder. X to the 3/2 power, we are going to multiply by my exponent and then subtract 1 from my exponent. So you got to think back to like 4th grade when you first did fractions, and you're going to take 3/2 minus 1. So we're going to subtract 2 over 2. So my new exponent is 1/2. 3/2 x to the 1/2 power. Know that this is the same thing as 3 times the square root of x over 2, because x to the 1/2 power is the same thing as square root. That's going to pop up all of the time. Make sure you got it. So let's do another one. Think about that one. The 4th root of x. Well, we don't like 4th root. If we see radicals in calculus, we want to rewrite them because we're better when it looks like that, x to the 1/4 power. And so if it looks like x to the 1/4 power, you multiply by your exponent. Let me make that less thick. Multiply by my exponent, and then I subtract 1 from my exponent. So I'm taking 1/4 minus 1, so minus 4/4. Oh, my exponent is negative 3/4. So this is my answer. That's fine. Know that that can be written in a ton of ways. Okay, that is the same thing as 1 over 4, and then I've got x to the negative 3/4 power. Well, the negative power puts the x on bottom. And then 3/4 is the same thing as x cubed and then 4th rooted. That's an algebra 2 concept. You have to this is fine. If you write it like this, great. But if it's multiple choice, you need to be able to recognize that that is the same thing as the other one. Okay, be able to go back and forth between those two. Next thing, negative integers, nothing really changes. We don't like fractions, and we don't like x on the bottom of fractions in calculus. So if you see something like this, like 1 over x to the 4th, be like, oh yeah, that's x to the negative 4th power. And then once you have that, we're going to do the same thing we've been doing. Multiply by my exponent, subtract 1 from my exponent. So if it's negative 4 and you subtract 1, my new exponent is going to be negative 5. So 1 over x to the 8th, that is x to the negative 8th power. I just rewrote it. Now I'm going to take the derivative. Negative 8, subtract 1 from my exponent. Sorry, I went by that fast. It was that right there. Negative 8, x to the negative 9th. I go quick, especially when I'm working by myself. 1 over the square root of x. Okay, that's the same thing as x to the negative 1/2 power. This one right here, this is the same thing as x to the negative 2/3. This is the root. And so if that's the root, it goes on the bottom of the fraction, just like roots of trees are on the bottom of trees. Roots are on the bottom of your fraction. Do those two real quick without me. It's very exciting to wait with me. All right, so x to the negative 1/2 multiplied by my exponent. Subtract 1 from my exponent, negative 3/2, because you're taking negative 1/2 minus 2 over 2. Multiply by my exponent. Subtract 1 from my exponent. This is, what would that be? Think about it. X to the negative 2/5. So the derivative would be negative 2/5. X to the, subtract 1 from my exponent. So 2/5 minus 1 would be negative 7/5. True or false, that right there is the same thing as that right there. Is this the same thing as this? No, they're not the same. I messed up the powers on purpose. It's going to be, oh, it's the 5th root, so the 5 goes there, and the 7 goes with my x, but it was negative, so it went on bottom. Okay, just be good with that. Okay, what happens if there's a number involved? Nothing. Okay, if there's a constant, we just take the derivative like we normally would. The derivative of u would be du over dx, and then multiply by whatever constant's there. Okay, so it means this. Oh, what do? I multiply by my exponent. So 4 times 5 is 20x, and then I subtract 1 from my exponent. Done. Multiply by my exponent. Subtract 1 from my exponent. No, I don't like that. That's really 4x to 1/2 power. What do? I multiply by my exponent. Subtract 1 from my exponent. Try those next 3 without me for a second. Surprise! Did you actually try them on your own, or are you just waiting for me to do them for you? Practice. Don't just do it on your own. All right, back to the football helmet because this is scary. All right, let's see if we can do it. Rewrite. I'm just going to rewrite this thing. 6t to the negative 1/3 power. Negative because it's on bottom. Then we take the derivative. Multiply by my exponent. Multiply by the exponent. 6 times negative 1/3 is negative 2t. And then I subtract 1 from my exponent, so it's going to be negative 4/3. This right here, I don't like that negative 5/3 like that, so I'm just going to rewrite it as negative 5/3 pulled out in front times x to the negative 3. I'd strongly suggest you doing that. It just makes it easier to see instead of having that x with that negative 3 multiplied by my exponent. So if I'm times negative 3, that's going to cancel. The two negatives are going to cancel. It's going to be 5x subtract 1 from my exponent. Last one. That is negative 12x to the negative 5/3 multiplied by my exponent. So it's going to be positive, and then 12 times 5/3. I'm going to reduce 12 and 3 because I can do that. 12 and 3 gets me 4. 4 times 5 is 20x. Then I subtract 1, so it's going to be negative 8/3. Boom. That's power rule. Power rule is pretty easy. Okay. Then we're going to change it up a little bit. Let's start doing more than one thing at a time. So sum and difference is the next one. So if we've got more than one part, we just do the exact same thing. Okay. If they're broken up with plus or minus signs, cool. You just take the derivative of each thing individually. So for example, x cubed, well, that is 3x squared. Multiply by the exponent, subtract 1 from my exponent. Multiply by that, subtract 1 from my exponent. Multiply by 1, so it's minus 7, and then I subtract 1 from my exponent, so it's going to be nothing, just minus 7, because it'd be x to the 0, which is just 1. Ugh, I don't like that, so that is 4x to the negative 1/2, because it's square rooted and it's on bottom. Multiply by negative 1/2, so it is going to be, sorry, I got distracted, I didn't want to be recording for nobody, minus 2. 4 times negative 1/2 minus 2, and then x to the negative 3/2. I don't have the ability for you guys to check my work, so I actually had to look at my notes to make sure I wasn't making a mistake. And then what's the derivative of negative 9? Nothing, because it's a constant. The derivative of constant is nothing. Boom, there's my answer. If we had something like this, we're going to learn something called chain rule, but we're not ready for that yet. And so we can't deal with this concept right now the way it's written. And so what I would have to do is multiply this out. So 2x minus 3, 2x minus 3. I would just have to multiply it out. And so I can make this 4x squared. And I'm good at math, so I'm going to FOIL it out without making all the baby steps in between. But it would be that. And then I would take the derivative of that. The derivative of that would be 8x minus 12. Boom, there's my answer. The 9 goes away. Same thing. We could do the same thing over here. Multiply, distribute. So this would be, what do I do when I take x to the 1/2 times 2x? Well, we're going to add exponents. This is going to be 1/2 plus a 1 right there. Remember, that is 2x to the 3/2. I'm not taking a derivative yet. I'm just putting those two things together. So it's 2x to the 3/2 power. Not negative. I don't know where that negative came from. Sorry. Minus, and then x to the 1/2 times x squared. That's minus x to the 5/2, because that's 2 plus a half. Then I just take the derivative. 2 times 3/2, the 2's would cancel. It's 3x, subtract 1 from my exponent. And then multiply by 5/2, and then subtract 1 from my exponent. Boom, there's my answer. We're doing good. Go through a couple more here, and then we'll call it a day for the first day of notes. I'm getting tired. It's late. Product rule. So if we have two things here, actually, I was going to do this. So let me just show you that what we're doing is not nonsense here. Let's look back at notes from the other day. So we started off with this. We had negative 2x squared plus 3x plus 9. When we did it, we said it took about 2 minutes, maybe 3 or 4 minutes when we did it. Now we'll be able to take this derivative really fast. Multiply by the exponent, subtract 1 from my exponent, and then the derivative of 3x is just 3. Done. That was my derivative. Hey, guess what? It's the same that we got doing it the long way. So it's really easy to do it this way. That's why we don't do it this way that we had done at the beginning. But it's important to learn. And again, we'll go over that later on. All right, back to where we were. We are on product rule. So product rule, if you are taking two functions and you are multiplying them together, you don't just take the derivative of each one individually. You have to do product rule. And this is something we're going to use quite a bit. Maybe not exactly like this every time, but we will show it use some more as we learn more calculus. But to do product rule, you're going to take whatever the first function is. So in this case, it would be u. And then we're going to multiply that by the derivative of whatever the second piece is. So here it was v, and so to represent that, they wrote dv over dx. So first times the derivative of the second plus the second, so the v here, times the derivative of the first, so we take the derivative of u. The first times the derivative of the second. First times the derivative of the second, plus second times the derivative of the first. That's what we're doing here. All right, so if we're taking the derivative of this, it's first times the derivative of the second, the derivative of this guy right here, x cubed plus 3. Well, that would be 3x squared. The derivative of 3 is nothing. So that's first times the derivative of the second, plus the second. So I'm just going to write that out, x cubed plus 3. That would in parentheses. Times the derivative of the first. So what's the derivative of that going to be? 2x. I'm just going to leave it like that. If we wanted to, we could FOIL that whole thing out and get a more simplified version. The wonderful thing about calculus, and we'll learn this the longer we go, is you don't have to simplify if it's free response. If this were a multiple choice question, yeah, we would simplify. But if this is a free response question, I'm leaving that ugly boy right there, and I'm going to call it a day. So try this next one, see if you can think about it for a second without me holding your hand. Derivative of the first times derivative of the second plus second times derivative of the first. Pause it if you need to. So first, and then I'm going to do derivative of the second plus the second times the derivative of the first. Let's do it. First, x squared minus x, boom, times the derivative of the second. The derivative of that is 3 plus second times the derivative of the first. The derivative of the first is going to be, I don't know why I wrote a 2 for second. Silly me. Let me try that again. This tells me that I need to go to bed here soon. Second, 3x plus 2 times the derivative of the first. The derivative of the first is that guy. The derivative of that is going to be 2x minus 1. Checking my work. Looks good. Product rule. Again, it looks kind of silly for this one, but it is what you need. All right. Last one of the night, quotient rule. So with quotient rule, you use quotient rule when you are dividing two functions. So if you're dividing two functions, you are going to set it up this way. So u divided by v. Well, the derivative of that is v times du dx minus u times du dx all over v squared. Or in other words, it's the bottom, whatever's on bottom. So if v is on bottom, it comes first. Bottom times the derivative of the top. Boom, boom. Minus the top. So what's on top? Well, that's the top. Boom, yellow. Times the derivative of the bottom. Boom, v. All over the bottom squared. That's hard. You got to memorize that, but that's a lot of words to remember. Okay? Here is my way of remembering that because that's pretty tricky. So, there I am. Hi. All right. So, when we're talking quotient rule, it can be confusing when we do it that way. And so we come up with this cool little catchphrase instead. So, when we're looking at this, all right, I got to go away. Hi. Okay, bye. Sorry, I was trying to be video, but it wasn't writing. Oh no, my pen quit working. It's like I'm at school. Oh, that's great. None of the things are working. Let me shut this down and see if I can run it again. That's what I get for trying to get you involved here. It's still not working. All right. Well, looks like I will continue this tomorrow when I restart my computer. We got you through most of it. We'll start with quotient rule tomorrow, and then we'll go from there. See you guys. Have a good night.